Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? How's home plate? Let's go. All right, really quick, just going to get you guys started. Warm-up number 17 should come up as soon as you log in. And once again, reminder, this session is being recorded, so if you need to access the lesson on YouTube, do so at the end of the day. Just also, second, if you look up over here really quick, look up. Hands off keyboards. I have a visitor that they're going to be with us. She's going to be with us for about a month or so, and she's going to be doing her observations. Soon to be a math teacher. Let's go. And this is Ms. Vargas. So if you see her walking around, hanging around, she's going to be here during this period and also next period. So, all right. So there you go. Any words for them?
Yes. So Ms. Vargas, I just graduated.
Do me a favor really quick, send your neighbor to go get you and them a calculator. You will need it for this session, please. Go. Calculators. All right. So warm-up number 17 reads, compute the standard deviation and graph on a bell curve. Says Mr. Q asked 6 students about how many hours they spent last night completing their homework from all their classes. One student said 2 hours. Another one said 4 hours. Another one said only half an hour of homework time. What? Another one 3 hours. Another one 5. And another one 2.5 hours. So, what do I do first? Brandon, go. Get us started. Read them. Uh-huh. 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 Hands, have you got that so far? Next, what do I do next? Pass someone? Mean. X bar, and you found 2.83. Hands, have you got that so far? That is correct, and do approximately. So then we subtract, for the sake of time, the mean from each of these data, 2.83, subtract 2.83, subtract 2.83, subtract 2.83, subtract 2.83, and subtract 2.83. All right? So, let's see. We got negative 2.33, negative 0.83, negative 0.33, this is 0.17, 1.17, sorry, 1.17, and 2.17. Hands if you're up to right there by yourself. Yeah, some of you, okay? What do I do next? Pass someone, Coley. Aaron J. Square them. So square this, square this, square this, square this, square this, square this. Let's see, calculators calculate. And Aaron, pass someone so they can give me those numbers squared. .42. What is it? 0.68. 0.10. 0.42. 02. 1.36. 4.70. Hands, have you got something like that? All right, some of us, all right. What do we do next? Pass someone, David. Austin S. So find the mean again. And what did you get, Austin S? 12 point what? Okay. for the mean. Let's see, 4 plus 1 is 5 plus 5 is 10, and these decimals are probably another 2. So I'm looking at 12, 13.8. Is that correct? What was it? For the mean? 2.04? 04 hands. Have you got something like that? Approximately, yes. And tell your neighbor the last step to get our standard deviation. Last step. What'd you get? Pass someone, Austin S. 1.43. What'd you do to get that? Square root of 2.04 hands. Have you got something like that? That is correct. Turn that into your screen, please. Did I send you the screen already? Yes. Yeah. Oh, the bell curve. Thank you. Let's go. Alessandra for Presidente. Let's go. So, mean, look up. Our mean is here, which is 2.83. And I'm only going one standard deviation up and one down. Look up, please. So according to this problem, 6 students, how many hours last night spent? Standard deviation is 1.43. So after one standard deviation up, where am I at? Tell your neighbor, please. After one standard deviation up, where am I at? Let's see. Looks like Logan got it. Where am I at, Logan? 4.26 hours. Looks about right. How about on the negative side? 1.40 hours. So that's going to be our norm. So that means that students completing their homework last night for all their classes went anywhere from what? 1.4 hours all the way to what? 4.25 hours, something like that. Okay? And then you write your observation in regards to what you see from the data presented. And there you go. You good? All right. Copy the agenda, please. Warm-up number 17 is done. We're still in the middle of standard deviation and normal curve. Block party, I'll address that a little bit more in a little bit. Yanni's all like, yes. And tonight's study. Yeah, because tomorrow's Friday. Tell you what's going on tomorrow. Let's go. We got this. Colleen. All right. If you're done copying the agenda, go to Canvas, turn in your home plate from last night. Only 2 problems. There were only 2 of them. 2 problems only. Turn that in, please. Also, I'm going to give you a code so you can access the presentation that I'm giving you today, and it's going to have all the slides so you can use that to study tonight. Okay? Here's the code. Copy this. C82LQ. C82LQ. Once again, all the slides are going to be in that code once you log into Nearpod. There it is. All right. I'll give you guys some time to turn that in on Canvas. Hurry up, hurry up, hurry up. All right. We good? All right, do me a favor, put away your notebooks. Ha, 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 ha. Ah, ha, 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 ha. Put away your notebooks. Ah. Hurry up, hurry up, hurry up. Notebooks, put away notebooks. All right, all you need is your Chromebook in front of you. You're going to need help from your neighbor on this one. So, really quick, let's see where we're at. So our objective, I wrote it as I can master percents, proportions, and standard deviation. Have we been covering that? Yes. And of course you did your own home play, right? Right. So then we should know what a ratio is, a proportion, a rate, and a unit rate. Is that correct? All right, talk it over your neighbor. What is a ratio? What is a proportion? Or at least give them an example of what it is. A proportion, a rate, and a unit rate. Talk it over your neighbor. What is each one of those? Talk it over your neighbor. Don't write it down. Don't write it down. Just talk it over. All right. So if I was to ask you in your own words, and if I was to call on someone in their own words, and I said either give me a definition or an example in your own words what it is, I would expect something like this. Look up. Comparison of two quantities. Or you should have given me an example using a fraction. Is that correct? All right. For a proportion, what would you have given me? A fraction equal to another fraction. How about rate? You would have given me a fraction by using two different measures. Miles per hour, miles per gallon, two different measures. Unit rate, one of these has to be a 1, and notice this one, the bottom one was a 1. Okay, that's the unit rate. All right. So from there, we did some examples that look like this. The ratio of the number of bones in the human ear to the number of bones in the skull is 3 to 11. There are 22 bones in the skull. Tell your neighbor how you would set up a ratio and then a proportion for that one. Remind your neighbor how to set up your ratio and then a proportion. All right, on your screen, write it, please. Write me the proportion. How would you set it up? Don't solve it, just write the proportion. I want to see that you remember how to start setting it up. 10, 9, 8, 7, 5, 4, 1 Mississippi. Answer on your screen from one of your colleagues. Hands, if you got something like that. That is correct. 3 over 11 equals x over 22. That's your initial proportion. We do cross multiplication and we solve, yes? All right, so now we know how to solve that. Let's go to the next one. We know how to solve proportions of any kind. Is that correct? Look at it. Tell your neighbor what to do and give them the answer, please. 20 seconds. Write your answer on the screen. Answer only. Answer on the screen. 10, 9, 5 Mississippi, 1 Mississippi. I said just write your answer. Don't write the process. You already talked the process with your neighbor. Oh, okay. All right, correct answer on your screen. Mississippi. There it is. Hands if you got M equals 15. Yeah, we got it, right? All right, from there we went to these kind. Look up. It's still proportion. Talk to your neighbor, let them know what to do for that one. Please do it all in your noodle. Come up with an answer. I'll give you a little bit more time. All right. Look up. Let's see if your neighbor said something like this. They said proportion, you cross multiply to the variable, but there's two terms now, so this is 2y minus 6. 6 times 7 is 42. Add 6. 2y equals 48. Divide by 2. Y equals 24. Hands, have you got something like that? Okay, good. So far so good. From 1 to 5, looking forward with proportions. We got it, right? But from there, we went to word problem and to a unit rate. Tell your neighbor the rate and then your proportion, how you're going to solve for the unit rate. Talk it over to your neighbor. How do you set it up? Only the setup. Only the setup. All right, write me your setup on the screen. Just the setup, write it on your screen. 10 Mississippi. About Imperial. 5 Imperial. 4 Imperial. A little bit faster, right? 3, 2, 1. Time. Look at your screen from one of your colleagues. Hands, have you got something like that? All right. So, we good, right? Next, we went to percent. And I said, percent is a compound word. Each part means something. Tell your neighbor what each part means. Talk to your neighbor, what does each part means in percent? Write me something on your screen. What does per mean? What does cent mean? 10 seconds. Ten, 9, 8, 7. Yeah, I did. All right, here's one from one of your colleagues on your screen. Per means multiply or times. Cent means 1 out of 100, and I gave you guys this screen that day, remember? Multiply, cent, 1/100th. So if we say 25% is 25 times 1/100th. From there we went to solve some of these, yes? So, we know how to solve these. Tell your neighbor the setup for this one. What would be the proportion setup for that one? Talk to your neighbor. See if they remember. Setup. The screen, if you want to show your neighbor, start writing to set up that one on your screen. 1 Mississippi. Here's the setup. Look up to your screen. Who wrote 48? Oh, sorry. There it is. From one of your colleagues, 48 over x equals 15 over 100. Hands if you got something like that. Yeah, and then cross multiply and solve. Are we there? All right. Next, from there, we went to standard deviation. I gave you guys the process. We know the process. I gave you a table to follow. We did that a couple of times. And now we're away from that table and we're doing it a little bit faster. Is that correct? But I wanted to know what the definition is. Tell your neighbor what standard stands for and deviation stands for. All right, type it up on your screen. In your own words, what is standard and what is deviation? What is standard and what is deviation? Carter, I think your screen is idling because I don't have anything over here. Mario as well. Oh, there it is. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Here goes one from your own colleagues. They wrote for standard, they wrote norm or custom. I'll go with that. And deviation, which means away from the norm or away from the custom. Yeah? And we use the example of the food, right? Most people have breakfast, lunch, and dinner, right? And then the deviation is that someone had more, someone had less, and so on and so forth. And there they are. Yeah? And last but not least, tell your neighbor what each of those lines represent. Talk to your neighbor. What does each of those lines represent on that normal curve? Start labeling on your screen. Start labeling that on your screen. What does each of those lines represent? Nine, 8, 7, 6, 5, 4, 3, 2, 1. And here's some of your artwork on the screen. There it is. Very nice. Some of you are writing with your feet. My goodness. Wow. So far so good, right? So from 1 to 5, how comfortable are you with what we've been presenting so far? Standard deviation, 5 fours, 5 fours. Yes, we just need a little bit more practice. Yeah. That's why today we're getting into groups of 2 or 3. So do me a favor, put away your Chromebooks. All you need is your calculators and get into teams of 2 or 3. 2 or 3. Hurry up, hurry up, hurry up. It's going to go fast, and if you don't divvy up the work, you're not going to finish on time. I'm just letting you know. This is due at the end. Here it goes. And it reads, you're going to get into teams of 2 or 3. You will create a poster that looks like this. Definition in your own words of standard deviation. You don't need your notes, you just need your teammates. You need to solve one word problem like you did on the warm-up and like you did last night. I'm going to give you that. You need to show the bell curve and you need to give me a conclusion to that problem. Now, 12th grade should give me like professional looking posters, right? So, you're going to take a picture at the end. The person that turns it in on Canvas, make sure you write on the notes that your teammates so I can give them credit as well. This is due at the end. Now check this out. Bam! I'm going to give you 2 options. Either you take option number 1, example super Q, that's already a word problem, but look at how many data I gave you. Now it's 10 data. It's a lot of numbers. Or you can make up your own word problem with only 5 data. So, here's my recommendation. If you're in teams of 2 or 3, one person's going to start writing the poster right away while the other person is copying the data and working it on paper first, doing all the computation while another one's doing the bell curve, and everybody's doing something or else you won't finish. So, with that said, blank sheets of paper in the back, markers are in the back, poster paper in the back. Let's get to work. Let's go. Those of you that are following on YouTube, make sure you do extra practice for yourself. There's that problem on your screen. And once again, do the extra practice. Talk to you guys later. Bye.